Hello class, this is Professor Munshi with Infotech Security ITSY 1442, and today I'm going to discuss lesson number 12, Analyzing Indicators of Compromise. So let's get started, and I'm going to go from my PowerPoint always to open up our chapter, our courseware, so you will know exactly which slide of mine corresponds to which portion or which section of the your actual coursework in the chapter. That way, you will know both at the same time, and you will be linked to the courseware. Later on, you can watch my video over and over again, and also go back to your courseware, and you can read the sections to learn more. So I think that will be more helpful. So let me try doing that today. So first, go to the chapter. This is lesson 12, analyzing indicators of compromise. What we're going to discuss in this chapter is when a compromise happens, meaning a security incident takes place. Then once it takes place or it is underway, it is taking place, there are some indications. There are some activities in our network, in some of the devices. If we could detect them, then we could detect the attack in the making early enough to perhaps contain it, perhaps to repel it, perhaps to protect ourselves to a large extent. Sometimes there would be indicators of attacks, an imminent incident or an attack. And there are some indicators in our traffic flow, in some of the activities of some applications or some systems, some server machines, some routers. If we could detect them before the attack takes place, then we could even prevent an attack. So let's discuss this chapter now. Okay, going to the slides. Okay, next one. Okay, analyzing the network events. One of the ways that we may be able to detect an imminent attack before it takes place, or the attack just began, and then we can detect it also by analyzing network events. What is a network events as opposed to what would be an event connected to, say, non-network per se, that relates to only an end device? Okay, a network event means, well, let's look at what a network is. Essentially, a network has many devices. You have your end devices like your computers, workstations, servers, laptops, phones, tablets, and printers, and all kind of end devices. Then you have intermediary devices such as routers, switches, firewalls, and so on. So now they are all the end devices are communicating via links that are established with the intermediary devices and so on. So now when an attack happens or a malfunction happens, any end device is malfunctioning, an intermediary device like a network device is malfunctioning, or any link has been affected in any way, there will be some indicators in the network. In our network traffic, we would see some pattern of change. If we could detect those patterns of change and understand them, then we would know how our network is performing, and that enables us to detect an incident early on by analyzing network. Okay, so what are some technologies for capturing network events? Anything that is happening in the network that can be captured, that can be analyzed. There are three technologies, three kind of systems that we implement, that we can use. One is the router based monitoring. There are some software such as NetFlow, SFlow, and JFlow. Any one of those can be used to capture our traffic, the sample packets that are traveling through network, and we can analyze them, and we can know what is taking place in our network. Okay, NetFlow is a software that's made by Cisco, and it comes with all the Cisco devices, Cisco routers and switches and firewalls and all of them. S-Flow is by HP, and J-Flow is by Juniper. NetFlow captures both inbound and outbound traffic, the packets, IP packets, and the JFlow and SFlow, they captures all the incoming inbound packets, and they don't take all the packets, they don't take repeated packets. For each type of packet, they get a sample. Now, that is router-based monitoring. Okay. Then you have another technology very widely used, very much industry standard, and that is RMON, or remote monitoring. Okay. This has been made to monitor the LAN devices, local area network, all the devices that are in the local area network. And they use this RMON uses a flow based information. And as the traffic is flowing through the network, it captures them, it analyzes them, it monitors them. So it's a network flow as opposed to how a device is functioning within itself, like how a server machine is functioning. Is there anything wrong with that server? Within the server, what is taking place? Armon would not directly take that information. Armon may be able to find that, but Armon is going to capture the flow of the traffic in the network, and by that traffic it may try to come up with conclusions of what's happening. Now, but the third one that I'm going to discuss, third technology, is SNMP, that is Simple Network Management Protocol. SNMP is a device-based, meaning each of the devices in the network will be configured to use SNMP, and there will be SNMP server, and all those devices will be sending their device information, device incidents and events and logs to the SNMP to let the server know their status. So this one is not flow based, this is more device based. Okay, so far we got three technologies for capturing network events. Now let's discuss, now this is discussed in 12.1, so let's look at our chapter also. Here is our 12.1, go all the way up in 12.1, and let's see right here. Here we discuss right here, capturing network events, NetFlow, Armon, all those are discussed here. Let's see where I'm in right now. Then we're going to discuss now active monitoring and passive monitoring. Okay, so let's talk about that. What is active monitoring? What is passive monitoring? Back to the PowerPoints. So it makes it easier going back and forth. Okay, active versus passive monitoring. Active monitoring is a type of monitoring in which you are actively reaching out, sending probes, sending some commands to your devices, to your routers, switches, end devices. So you are reaching out to those devices, such as the command like ping command. Okay, if you send a ping to another device, that device is supposed to answer back to you if this device is up and running normally, and your device, your computer is going to send a ICMP package. Okay, inter-network control messaging protocol, a small packet of data, several packets is going to be sent. The destination device is going to answer. That's how you know the ping command is going to say that yes, the reply received from this IP address, or it's going to say destination unreachable, or destination did not respond, or no response, things like that, some kind of message that you're going to get. So by that message you would know your destination host is reachable. If it is up and running, that information can be understood. iPerf, this another utility, it's an open source utility. It tests bandwidth of the network. Okay, iPerf, that this one is multi-platform, meaning if you have Linux based systems, Windows based systems, any kind of systems that you have, different kind of operating system, you can use iPerf. You can download or install that utility, and you can use the iPerf utility to test network bandwidth from it. And how it does it, one device sends some data to the other device, to the receiving device, we call it server. And then how fast the data reached there, how much data, what is the amount of data reached to the server. By that, we can measure the bandwidth, we can measure the throughput, actually, what is the performance of the network. Okay, so iPerf is a good thing. Now, these are all active monitoring tools because you are using a command, a utility to talk to the, to reach out to another device. Now let's talk about passive monitoring. Passive monitoring, you are not contacting another device, a destination device, via some kind of command or utility. In the passive monitoring, you just have a network tap, something that snips the data, copies all the communication from a network link, and keeps that data. Later on, you can analyze that data and find out what kind of communication was taking place, what packets were traveling through the link. This is called passive monitoring because you are not actively reaching out to any of the devices in your network. Okay. Okay. Next. So now some of the tools, some of the software that is used to to check the overall health of a network. Okay, that this kind of tools would combine all the data, all the analyzable data, traffic, network data. For example, you may be using NetFlow, SFlow, you may be using SNMP. So all of those you want to combine into one place and get an overall health from all those flow data or device data, so that you can come up with a conclusion, in a general conclusion of the health of your network. Such a tool is PRTG. That's called Passler Router Traffic Grapher. PRTG is a software tool. It is developed by PRTG AG. It monitors bandwidth usage. Bandwidth, is the measure of data, how much data travels through your network. For example, if a link between your computer and your router or your switch is 100 mbps, 100 megabits per second, that's your bandwidth. You would like to see how much of that is currently being used, if your link or a device being overwhelmed. So now this PRTG, this tool combines again all of those kind of flow data and combines them all together, makes a beautiful report for you. Now, it's also multi-platform. So whether you have Windows-based machines, Linux or Mac, it can work with all the platforms. And it uses the four types of monitoring combines together: packet sniffing, flow control, SNMP, and Windows management instrument. Now, the PRTG is not the only tool that you have for combining all the network events, okay, combining all the network event captured events. For example, the SolarWinds, they make several monitoring tools. One of them is Network Performance Monitoring, NPM. Then you have Nagios, Network and System Monitoring. You have Cacti, SNMP device status. There are some more notable tools. Okay. Next. So now, detecting network issues. Let's visit our chapter and see where we are at. So we got the active and passive monitoring, covered that. Network monitoring tools, we are discussing that, we just discussed that, PRTG. Okay, so let's correspond to our SolarWinds, Cacti. Good. Now we're going to talk about the how to detect some network issues. Okay, what are the ways to detect network? What are the symptoms that we detect? One would be bandwidth consumption. Okay, how much bandwidth is being used? For example, so let's go back to our PowerPoint first. Okay, detecting network issues. So bandwidth consumption is one big thing that we want to know. That tells us the health of our network at the moment. If our bandwidth is near its capacity, we know that we may get outages, because if bandwidth is overly consumed, then we may get an outage or a disruption in our service. Okay, the monitoring tools like PRTG again helps you to know the status of your bandwidth. Now, how do we also detect beaconing? That is very important one. If an attacker is going to launch a DOS, denial of service, or a DDoS, distributed denial of service, those kind of attacks, or any other kind of attack, sometimes the most of the time actually the attackers will first have some one or more of your devices in your network under his control. This is a compromised device. This is called a zombie. Now it is acting, your device now, which is compromised, is acting as a staging ground for the attacker. And the attacker has something called a CNC, okay, command and control server. So the attacker now is controlling your network devices or your end devices from his command and control server. And he's about to launch an attack. Before he launches the attack, your devices, the zombie devices, they would be sending signals. They would be telling the command and control, that is, I'm already here, go ahead and start attacking, send the packet, some kind of communication. This communication is called beaconing. So this is a communication between the compromised device in your network and the command and control server in the with the attacker's premises. So if you can detect this beaconing communication, you possibly will be able to detect an imminent attack, and you will be able to possibly prevent an attack. What kind of system, what kind of device, what kind of tools do we use to detect beaconing? We use IDS or IPS. IDS is intrusion detection system. IPS is intrusion prevention system. Okay, this kind of devices, they are hardware devices and they are software devices. There are some IDS or IPS could be just software, or could be a hardware and software together. So they always analyze the network flow that is passing through, and it checks the pattern of communication. Okay, now we also want to detect unexpected traffic. There are some traffic that we don't expect, that are not needed, but they are like unwanted guests in our network. An example would be scans or probes. Um, Sometimes, I mean, not that's actually very often, more often than an attack happens. The attackers always launch probes and scans against our network before attacking it. They do that for a long time, very often, very frequently. Those scans, like they scan for ports to see which ports are listening, which ports are open in our systems, which ports that they can enter through, or which services are active, which services are running, accepting, inbound traffic, inbound requests. So they always would be scanning our network. Okay, so if we can detect those scans, the protocol analyzers, they can be used. What are the protocol analyzers? Anything that snips data, okay, like Wireshark, for example, something that captures data. Even the PRTG does the same thing, capturing data. There are many devices, many tools that are there that can capture network data and to analyze it. Those are called protocol analyzer or packet analyzer. Okay, we can use them, those kind of devices, to analyze, to see if there is any unexpected traffic that we can detect. Okay, now next is detecting scans and probes. How do we exactly detect the scan and probes? Let's talk a little bit more about that. I'm still in 12.1. Let's go back there. So every time we get a new slide, we should actually go back and see our chapter, so you can be more familiar and you become more comfortable coming visiting your chapter, and you will know, you will have the confidence that I am discussing your chapter actually. Look at the unexpected traffic. Okay, that's where I'm at. So we're going to be discussing unexpected traffic. So like scans and probes, for example. Okay, so now I go here to my back to my PowerPoint. Okay, again we use IDS or IPS, intrusion detection system or intrusion prevention system, that is always monitoring our traffic. To then it can analyze the pattern or behavior of the traffic. Okay, now when a port scan is happening or an IP scan is taking place, you will see a pattern of traffic that always scanning one by one port in a sequential order. Or there are many at the same time, too many ping requests are taking place. And you're going to be also seeing that too many service requests at the same time sequentially coming. Then you know that someone is launching a scan against our network. Now, let's talk about some symptoms that and some tools that we use to know those symptoms before a DOS or DDoS attack takes place. Again, the denial of service and the distributed denial of service, those kind of attacks are against networks, against server machines. So the whole entire server will be down, or many servers will be down, or our network itself will be down. Our router could be overwhelmed. Okay, so network devices or server devices could be down, and the network will experience outage or disruption. So DOS and DDoS essentially the same thing, but DDoS is more massive, more distributed throughout the network. Now, you will be one of the symptoms that you will be seeing before a DDoS attack. There's an overwhelming amount of service requests in a network. Okay, so performance monitoring tools, bandwidth monitoring tools, such as PRTG, those kind of tools can be used to detect the pattern. Of course, IDS, IPS again is very big on this. They will be seeing this pattern and will report to you an abnormal pattern of service requests. Now, last thing we need to use, we need to talk about in detecting is detecting rogue devices. What is a rogue device? A device that is connected to your network that you did not authorize. That is actually not your device. An attacker or a hacker, they actually brought their device and connected to your network either through wire or wirelessly. And that device is acting as a part of one of the devices in your network, but is controlled by the attacker. So he's via that device, he's able to communicate with rest many of other devices of your network, many of the other devices of your network, and then gets he is able to infiltrate, he's able to know a lot of information, he's able to log into other devices and cause damage and launch attacks. So you want to detect those devices in a big network where hundreds of devices or thousands of devices are present in enterprise network. Easily an additional device or a few additional devices can be installed without your notice. So how do you detect? One thing you can do is to validate MAC address. So if you have in your inventory a list of MAC addresses that are supposed to be that belong to your legitimate devices, then after you try to validate MAC addresses of a device, you will know whether that MAC address is in your list or not, whether that MAC address or that device should be in your network or not. Another would be you can scan the entire network to check what devices are present. You can do a site survey and so on. Okay, let's go to the next slide. Next slide, we're going to now 12.2, investigating host related issues. So far we have talked about network, capturing data from the network, seeing the health of the network, seeing the bandwidth usage, pattern of communication we discussed already. Now we're going to discuss not just the network communication, one end device, a server machine or a host workstation machine. One of your devices has malware, one of your devices has infection. Then we need to detect them, monitor them as well. Okay, let's check in our chapter. Where is that? 12.2. So let's go up all the way to the 12.2 right here. Okay, investigating host related issues. Okay, so you check system resources, how much of your processor being used, how much your memory being used. That gives you an idea what's going on, if there's anything abnormal going on in your machine. So back to the PowerPoints. Okay, now monitor the system resource as we are seeing there in the chapter. You check the utilization of memory, processor, disk space, any of the resource that you have, hardware resource in particular. You check how much of your resource is being used, whether your system is being overwhelmed. And there are some tools in your operating system. Okay, Windows tools would be your resource monitor in Windows, or performance monitors that gives much more detail, and they are easy to find out. I can type here resource monitor, and you're going to see it's going to show, or performance monitor. For example, let me show you the performance monitor. Just one of them I can show. Look, performance monitor. So I open it in my computer, and you will see that it shows the usage of my CPU, memory, disk space, and a whole lot of in the graph, in many different formats, many different. Let's see if I can move this window. Takes a little bit moment, and then we'll also discuss the Linux. In the Linux operating system, you have some commands, some utilities also, like ps command provides CPU and memory utilization. Top command shows your CPU memory running processes. Df command shows your disk space usage. Okay, so now for the Windows, just I'm giving you an example so you can see. This is your performance monitor. Okay, performance monitor shows exactly how much memory is being used. Okay, network interface, your physical disk, your processor, all this, it shows. Now this is the system summary, and if you go, normally you have several different ways of view and data collection. But anyway, I'm not going to go into detail, so let me just actually close it and go back to my slides. Okay, next slide. Detecting malware. So we need to be focused on our chapter. How do we detect if my device, any device, server, workstation, computer, PC, anything, has gotten some malware? Okay, so one of the ways to manage, to detect, is Microsoft Endpoint Configuration Manager. This is a good tool that we use. Microsoft Endpoint Configuration Manager. This can manage a large number of systems. What it does, it automates in an enterprise level, software installation, updating the operating system, deploying the new machines, creating the system image, and patching, and always keeping the security up to date, keeping the inventory of the hardware and software. Basically, you are managing software, application, operating systems, update, installation, everything by an automated machine. If there is something else somebody tries to install, it will be reported. Okay, so you have that endpoint configuration manager made by Microsoft. That's one. How do you detect abnormal operating system behavior? Okay, sometimes rootkits are a very serious form of malware that can cause the operating system itself to behave abnormally. Okay, you use, and also there are some, what tools do we use? Let's talk about that. CMD is the command prompt, WMIC, PowerShell. These are kind of, shell prompts to type your commands, and you can run some of your software, some of your utilities, some of the commands to to diagnose, to monitor, to verify. So these are your some of the commands that you use in the command prompt mode. Now, lastly, detecting unauthorized access. You want to detect if there is any other account that is existing in our system that we did not create, a rogue account. An attacker was able to create a user account and able to log in to our machine. We want to detect that. Okay, so we can analyze the system logs, such as application logs, security logs. Okay, you can find those, for example, in the event viewer. So if I go click on here, and I go to event viewer, EVENT, type event, and I'm going to see event viewer is going to show up, and I click on it. So it takes a little bit time, because it's a huge software utility that loads, it takes a little bit of time to load. So, and then you also use some other tools like your SIM system, security, information, and event management. This kind of SIM system, uh, there's a spelling error in there, TEM, okay. SIM systems you use, okay. Also, we use file and directory integrity checker, okay. So it will check whether our operating system files are sound, whether they have been corrupted. There are some integrity checker. An example would be OSSEC, like operating system security. OSSEC is an open source utility that you can download and use in your machine to check the integrity of your operating systems files. Okay, then SolarWinds, Qualys, many other vendors, Tripwire, they do make some other tools that can check file and they call it like file integrity management. FIM is the category of the software. Okay, so we use those kind of software to check the integrity. Okay, let's go next slide. Application and service monitoring. Okay, so let's go back to our chapter courseware to see where we're at. Okay, so we just finished probably the number 12.2. Now we're going to be talking about something else. Okay, Windows task scheduler. These are all Windows tools that we use to check unauthorized access, changes in privilege. Okay, so now 12.3 is where we're going to go. Okay, here is 12.3, and we're going to discuss here investigating service and application related issues. Now we're talking about a software program that may be crashing, that may be behaving abnormally, that may have been infected by virus or malware. Okay, maybe one of the services that is running in our machine that is not functioning properly, that has been corrupted, so that have been disrupted by attackers or some kind of malware. So we want to monitor the applications and services. How do we do that? That's what we are discussing right now. Okay, application and service monitoring. So now let's go back to our PowerPoint. Okay, what is as far as service is concerned, like dial-up service, remote monitoring service. Okay, any kind of service that is running off of your PC. Okay, uh, they whether that service is up or down, that's an indication. You're monitoring, why is my service down? Okay, why is the service not performing as expected? Should be a question mark there. Okay, so these are the questions you ask when you look at the services. Is the service up or down? Okay, is the service performing as expected? What actions did users perform? You want to see those things in the log. By the way, I was talking about the event viewer. Now finally event viewer came on. So let me move this here and see if I can show you. This is the event viewer. In our Windows system, for example, it logs everything. Every event that takes place in my computer is always logged. Okay. I go here, I'm seeing the event viewer. I go to the Windows log. If I click on it, then I'm going to say, wow, this is application logs. So all the software application, somebody launching the application, somebody closing the application has an error, application started, anything would be always logged. Okay, it's taking time, so it's not showing. It's coming up. If I wait and wait, it's going to show. It's going to populate this window. Then I have security log. Okay, all the security event is logged in here. I have setup log, system log, things like that. So I'm gonna, for example, the application log, I'm gonna keep it like that, and I'm gonna wait for a little bit, so it populates. Okay, go back to my PowerPoint. Okay, now analyze logs to detect. Okay, so I just showed you in the event viewer, you have the application logs, you have the security logs, system log, those kind of logs you can see in any machine, not just Windows machine. Linux machine has logs, even routers, switches, all the devices that function in the network, connect to the network, all of them have some kind of logs on their own. And you can analyze those logs and try to detect if there's anything wrong is taking place in a particular device. Okay, so let me see if it is up now. Okay, It takes a long time. Okay. Okay. Let's see if I could do refresh. Okay. But anyway, so I wouldn't take much time. So here is your that's how where you go to see your event logs. Okay. This is just an example that Windows has its logs. Okay, right here, look, finally it's populating the application log. It shows the information, what exactly happened, what time, and what exactly happened. Security SPP, 4:14, 12, 2:1 p.m. Okay, all those things. And if you click on one of the logs, that's going to show the detail underneath, exactly what happened, more detail about that particular event. Okay, if I go, see, these are all information. If there's an error, would be red color. Look at that, red error. Okay, giving you an example of a log. So let me close it now. Okay, so you saw the logs, how to check the logs. Okay, now also antivirus and anti-malware, that's I didn't talk about much. These tools are very serious tools. Antivirus, anti-malware, that kind of tool should be very much in action and on guard in your network, in your end devices. Every server machine, every workstation, every end device definitely should have some kind of antivirus protection, anti-malware protection. And of course, file and integrity checker. As I mentioned earlier, file integrity management, FIM, that kind of software, okay, like OSSEC, they will be used. I can write here like OSSEC, okay, that, okay. So now we check them. Now, tools for checking service status. Now, if you want to see all the services that are supposed to be running right now in my PC, what command do I type? I just have to type services.msc, and the services console is going to open up, and I will be seeing so many services are there. Some are up, some are down, some are manual, some are automatic. Okay, some has stopped. It's going to show. Linux has also a service command. Okay, let me show you in my Windows how do I check all my services. I click on the magnifying glass and I'm going to type service, service. Go to services. Look at this app, services app shows up. Again, this kind of utilities takes a little bit time to load. So in the meantime, I'm going to go to the next slide and see what we are going to discuss in the next slide. Okay. Now, detecting attacks on application. Application means a software. Okay. Okay. Yeah, my services has come up. So let me show you. Here is my services console. It shows all the services, the name of the service, the description, status, running. Some of them are running. Some of them are says a startup type, manual or automatic. This one is automatic startup. Okay. I could even move these ones, these panes, these columns, to make it more wide to read more description about it. Okay, and sometimes the name is not showing all the way. Okay, now look at each of the service, the description, status, startup type, log on as, everything's there, all kind of service that are running in my computer right now. So let me close it. Okay, now talk about the detecting attacks on application. So go back to the chapter again. Every slide we should do that. Okay, application error monitoring, application behavior analysis, okay, application and service issues response and restoration, detecting attacks on application. That's what we're discussing right now. Okay, how do you detect attacks on application? We know that an application or a software can be infected, can be attacked, and can be compromised. There are some behavior that it will show that will concern us, that will make us look more detail into them. What kind of behavior are we talking about? When a software is having some anomalous activity. Every software that you run, it has its normal behavior. Sometimes you click on something in that software, click on an option, and it does not show up, it's not functioning. Then you get concerned that something is not working right with the software. Okay. Number two could be presence of a new account, that you have three people, you have a administrator and you have David and you have a user, whatever account you have. All of a sudden you have another account, Eric. Well, that account I didn't create. who created this account in this particular software. Okay, many softwares requires you to log in with an account. Okay, so then if you see a unknown account, a unwanted account, that's an indication that somebody may be accessing this software. Unexpected output. You are running the software, trying to create a report using the software per se, and just garbage shows up or error shows up. That could be a concern. Unexpected outbound communication. You see that this software is sending data to somewhere continuously. Okay, or whenever you are not expecting it to send out data, it is doing so. Service interruption. Okay, that some of the services, as I mentioned, that relates to this particular software is disrupted or being restarted. And memory overflow, like this software is crashing or freezing. When you see this kind of behavior, then you are concerned that something happened to the software. Perhaps the software has been infected, perhaps the software has been damaged, maybe the software need to be repaired or uninstalled and reinstalled and whatnot. Okay, so this was our chapter all the way. I hope that you will find this video now more helpful to you. And so this is your chapter 12, and the rest of the chapters I'm going to be posting videos also each week. So have a great day for now, and I'll see you again with next video for the next